All right, reviewing back to yesterday when we started this activity using transformations to prove the triangle sum theorem, we started out with some patty paper and taking that original triangle and translating it. And then we said, okay, well, how can we map the original triangle onto that triangle in the middle that we shaded in? And we talked about how that could be done in various ways. And then we noticed at the bottom there along that segment AC, we had all three angles, angle A, angle B, and angle C. And we discovered that anytime we have angles up against a straight line, they have to add up to 180 degrees. And that's because a straight line represents half of a circle. So we said they make a straight line which measures 180 degrees. Well, when we moved those angles around, when we were translating or rotating those triangles, we weren't changing the size of the angles. We were using rigid motion, with your reflection, your translation, and your rotation are all forms of rigid motion, meaning when you move the object, you don't change the size or the shape. So it stayed. The last thing we were working on, I believe just as the bell rang in here, was on this conjecture. And a conjecture, again, is nothing more than an educated guess. Do you think that you would get the same sum for the interior angles of any triangle? Why or why not? I'm going to pause for a moment because if I remember correctly, we were just getting to that as the bell rang yesterday. So I'm going to pause and give you a moment to think about that and get your answer in. Remembering, conjecture is an educated guess, which is really kind of like your opinion based on what we've talked about. So it's not about being right or wrong. It's just you expressing your opinion. I am not going to be writing in an answer here because this is what you think at this point. So I'm going to pause for a few moments to make sure you go ahead and answer question number 8. So as we just discussed on this number 8, really this same idea could be applied to any triangle, not just this one specific triangle. You could all draw a different triangle and we could come to this same conclusion, which brings us to the next page. You have just informally proved the triangle sum theorem. So the triangle sum theorem, what it says, and we're going to talk about theorems a little bit later in the chapter, but the idea of the triangle sum theorem is that the sum of the interior angles of any triangle is 180 degrees. The sum of the interior angles of any triangle is 180 degrees. And I'm going to draw some examples of some different types of triangles, and it would still work for all of them, whether our triangle looks like this, like this, or like this. It doesn't matter. The theorem says that the angles in a triangle are always going to add up to 180. And we can write that out as the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Now, we're going to learn in geometry that there are a lot of symbols used to shortcut us having to write everything out, because geometry is really about what can we prove. And when you're proving something, you're usually having to explain why that can happen. Well, if you're doing a lot of explaining, you don't want to have to do a lot of writing. So for example, if we take this here where it has the lowercase m, the angle symbol, and A, just so we know how that is read, that is the same thing as saying the measure of angle A. Now, isn't it nicer to write out 3 things instead of having to write out that entire sentence every time you want to talk about the measure of angle A? So as we go on, you're going to learn we use a lot of symbols in geometry. We're going to see a little bit later, we use a lot of markings on diagrams to help give us information. So geometry tries to use as many, I hate to say the word shortcuts, like we're trying to do something not full to its full potential, but there are things they give us to make it a little easier instead of having to write out all these words. Because if we had to write out that sentence and say the measure of angle A plus the measure of angle B plus the measure of angle C, that's a lot to have to write out. So again, we're going to be looking at a lot of things to shortcut that. All right, after completing the lesson you have just done, 3 friends were talking at lunch. Read their statements below and decide which students you think are correct. Khan says, now that we know the total number of degrees in a triangle, all we need to know is one of the angles to figure out the others. Maricela says, but there are so many ways to add up to 180. I think you'd need to know all 3 angles to be able to draw the triangle. Once you knew all 3, though, you could only draw 1 triangle. And Angel says 2 angles would be enough to know. I bet I could figure out the 3rd angle if you gave me 2 of them. Then I could draw the triangle. So I'm going to give you a few minutes to write about what you agree with and what you think is wrong of what Khan, Maricela, and Angel have said there. So I'm going to pause for a couple minutes here. All right, so what do we think? Who would like to share? What did you agree with? Let's just start with that part. What did we agree with what was said? Based on what we know now about triangles, what did we agree with here? Why, Angel? Right, so if I only have 1 angle, let's say I know that angle is 34 degrees. I subtract that 34 degrees from 180. What that leaves me still 146 degrees. And if I don't have any other information, I don't know how to divide that 146 between the 2 other angles. So 1 angle is not enough because it would tell me what the other 2 have to add up to, but it wouldn't give me the information to find out both of them specifically. Why not Maricela, though? Why don't I need all 3? Right, so if I have 2 of them, if I know they always have to add up to 180 and I have 2 of them, I can add those 2 together, subtract from 180, and that tells me what the 3rd one is. Now, Maricela is not wrong. Having all 3 is nice, but something that Maricela is wrong about in her statement, she said if I have all 3, I would be able to draw the triangle. And once you know that, you could only draw 1 triangle. And that's not true. Just because we know the angle measures does not mean we know the side lengths. And we are going to find out later this unit that there is a relationship between angle measure and side length, but not enough of a relationship for me to be able to say, oh, if that angle is 34, then that side length is whatever. There is a relationship, but it doesn't tell me exactly. So knowing all 3 angles, there's not just 1 triangle that will have that angle measure, those 3 angle measures. There could be various different side lengths that still have those angle measures. So Angel was the most correct, as you said, that if I know 2, I can add them together, subtract from 180, and I will know the third one. And that is really the idea that the triangle sum theorem is kind of built on, and being able to use that to solve, which in the next part, that's really what we're doing. We're taking that theorem, and now we're actually going to apply it to solving problems. I told you just because we're doing geometry doesn't mean we're not doing any algebra, because a lot of geometry uses algebra to solve. So they want us to use the triangle sum theorem to find the measure of the missing angle. So they give me a triangle with degrees of 56 degrees, 68 degrees, and x degrees. Well, again, the triangle sum theorem just said if I take that 56 plus that 68 plus x, I know that all together they have to equal to 180. $56 plus 68 is what? 124. So 124 plus x has to equal 180. So to find x, I just need to subtract this 124 from both sides. And what does x equal? $56. So x degrees is 56 degrees. All right, number 2, we have 38 degrees, 58 degrees, and x degrees. It doesn't matter what order you put them in to add them, because when you add, you can add in any order. So if I go x plus 38 plus 58 equals 180, I usually pick a starting point and then I just go clockwise around the diagram. So here I have 38 and 58 that I need to combine. So x plus, what is 38 plus 58? 96. So x plus 96 equals 180. So if I subtract 96 from both sides, it's going to tell me what is left for that x. What is 180 minus 96? 84. So x degrees is 84 degrees. All right, number 3. Number 3, they're telling me one of the angles is x and one of the angles is 30. What are they telling me right here? What does this box mean? It means it's a right angle and it's 90 degrees. I told you they use a lot of symbols and markings. So that box is telling us we have a right angle, and if we have a right angle, yes, that does mean that that is 90 degrees. So I need to be able to recognize that on a diagram. So I have 90 plus 30 plus x equals 180. So what is 90 plus 30? 120 plus x equals 180. And if I subtract that 120 from both sides, what does x equal? 60. So x degrees is 60 degrees. Now in number 4, there's 2 angles that both have x degrees, and that's fine. They can both have the same. That still gives me enough information, because I can say x plus 32 has to equal 180. The only difference here is now when I go to combine, I'm actually combining the x plus x instead of combining numbers. So what is 1x plus 1x?
2x.
when we are combining like terms, we are just adding the numbers in front of them and keeping the variable the same. So we have 2x plus 32 equals 180. Subtract 32 from both sides. And what does 2x equal? What is 180 minus 32? 148. And then to find x, I need to divide both sides by 2. So what does x equal? 74. So x degrees is 74 degrees. So that's just a single variable. In the next couple of problems, instead of just giving us a single variable, they're going to give us some expressions that we're going to have to solve for x first, and then they want us to find each missing angle measure. So number 5, we have x degrees, 2x degrees, and x minus 16 degrees. So the equation, again, is going to be adding all three of those up. So we're going to have x plus 2x plus the quantity x minus 16 equals 180. So here, the first step, I need to combine like terms. So I have x plus 2x plus x. How much does that add up to? So 4x minus 16 equals 180. So now to get that x by itself, I need to add 16 to both sides. So 4x equals 196. And then the last step, I need to go in and divide both sides by 4. So what does x equal? What is 196 divided by 4? It is not 46. Close.
49.
It is 49. So if x equals 49, then I need to substitute that 49 back in for x. Now this one angle on the bottom left is just x, so that's going to be 49 degrees. 2x means I'm going to take 2 times 49. What is 2 times 49? 98. So this angle is 98 degrees. And here x minus 16 means I'm going to do 49 minus 16, which equals 33 degrees. It does not matter what order you write them down there at the bottom. I'm just going to go 49 degrees, 98 degrees, 33 degrees. The way that you can check to make sure you've done all your math correctly, if you add 49 plus 98 plus 33, you should get 180. If you don't get 180, you need to go back and check your math. Because again, they always have to add up to 180. All right, number 6. We're going to have x plus the quantity x minus 27 equals 180. So I need to add all of these x's together to give me 3x minus 27 equals 180. I'm going to add that 27 to both sides to get 3x equals 207. Divide by 3 to get x equals 69. So two of the angles are x, so I know this angle is 69 degrees, this angle is 69 degrees, and up here I have 69 minus 27, which comes out to 42 degrees. So 69 degrees, 42 degrees, and 69 degrees.